a readiness team, and in some cases actually it's the same team, in some cases are different teams. And examples include the US CERT, the Indian Computer Emergency Response Team, CERT Australia, and the Australian emergency or computer emergency response team, and many more, right? Now, the Forum of Incident Response and Security Teams, otherwise known as FIRST, they actually have a list of all the national CERTs and other incident response teams at the link that I'm actually sharing in this screen, right? Now, these national CERTs and CSIRTs aim to protect their citizens by actually providing security vulnerability information, by providing security awareness training, also by sharing best practices and many other information that can be useful, for their citizens, right? For example, this is the US CERT mission that is actually posted at, the link that I'm actually sharing here. And, some of the missions, for this CERT, and specifically in this case, the US CERT, the mission activities include things like providing cybersecurity protection to federal, civilian, executive branch agencies through intrusion detection and prevention capabilities, also to develop timely and actionable information for distribution to federal departments and also federal agencies, right? They also support state, local, and other territorial, governments, institutions, within the country, right? They also provide information to how to protect critical infrastructures, right? So specific for critical infrastructure owners and operators, and also to the private industry and also international organizations in some cases, right? They provide guidelines on how to respond to incidents and analyze data about emerging cyber threats, right? And they also collaborate with foreign governments and international entities to be able to actually enhance the nation's cybersecurity posture, right? Now, there are also several organizations around the world that help with the coordination of security vulnerability disclosures to vendors, hardware and software providers, and security researchers as well, right? One of the best examples is the CERT division of the Software Engineering Institute, which can, be accessed at the website that I'm actually sharing here, or cert.org. And basically, their about page actually summarizes well their role and the responsibility of not only their coordination center, but also many coordination centers alike, right? So here I'm actually sharing the about page, for your reference. Now, in their case, actually, they're more than just a research organization. They actually work with software vendors to actually help resolve software vulnerabilities. They even develop tools and methodologies that actually are used by many other folks within the industry, right? So again, there are many different resources, within each country, and a perfect example is the US CERT and also the CERT Coordination Center. Provide incident response and manage security services to their customers. These incident response teams and outsourced CSIRTs, they operate a little bit different than the traditional CSIRT. And this is because their task is to provide support to their customers. However, they actually practice the task that we actually mentioned earlier in the previous lessons, right? For incident response and for, CSIRTs. Now, here are a few examples of these type of teams and their services, right? So Cisco's incident response service is actually a service that is provided to Cisco customers, both for enhancing the readiness of of that customer to be able to proactively address an attack or prepare for an incident, right? And also they provide post-breach support, right? The proactive servers include things like infrastructure breach preparation and different assessments that they actually make, around the operations, the security operations of their customers, and also how the customer should communicate internally and externally, part of the incident response plan and the process, and also security operations and incident response training, right? Now, the post-breach or the reactive service includes the evaluation and investigations of the attack, also countermeasure development and deployment. They also help with the validation of the countermeasures and their effectiveness, right? I'm just sharing here a link that actually has more information about the Cisco Incident Response Service, just for your reference, right? Now, there's a managed security service by Cisco, the Cisco ATA, or Active Threat Analytics, and basically what they do is they provide a service that can monitor their customers' network 24/7, right? They do continuous monitoring and advanced analytic capabilities combined with threat intelligence and security, analysts and investigators are actually available to help detect security incidents and security threats within the customer's network, and then of course create tickets and help them mitigate, those issues. So again, I'm actually just including here another reference to the Cisco ATA service, right? So they also have different capabilities in place, and even they share some knowledge that can help you whenever you're actually creating a security operations center within the organization. If you learn the incident response process and guidelines provided by the National Institute of Standards and Technology, otherwise known as NIST, you learn details about each of the steps in the incident handling process and the incident response, of course, methodology. Now, in this lesson, you will learn how to apply an industry-led vocabulary for incident handling called VERIS. And VERIS stands for Vocabulary of Event Recording and Incident Sharing, right? So it was first created to describe the different aspects of incident handling and the incident narrative in a standard format. VERIS was originally created by Verizon and other members of the security community, and it has been adopted by many organizations in the industry. As a matter of fact, we actually use it at Cisco, both for the security operations to protect Cisco, and also for a managed security service called ATA, or Advanced Threat Analytics, where we actually manage and monitor customers' network, right? So now going back to VERIS, the overall goal of VERIS is so that the industry participants and cybersecurity professionals can actually learn from our experiences to better measure and manage risk, right? So the VERIS schema is actually documented in different sections, and specifically in 5 different categories, right? So the first one is incident tracking. Second one is victim demographics. The third one is the incident description, incident discovery and response, and the impact assessment, right? So you can view the schema documentation at the website that I'm actually showing in the screen, and the actual schema files, along with several examples, are available at GitHub, as I'm actually showing here. Covered in the VERIS schema. VERIS allows you to capture general information about the actual incident. It provides you with the ability to assign an incident ID, and this is actually used for better tracking the data and, of course, the incident. And you can also assign an ID to the source of the incident data. Also, you can describe whether the incident has been confirmed or it has not been confirmed. Of course, it allows you to document an incident summary, associate other related incidents, any type of incidents that might be related to this specific one, and also assign a confidence rating. Now, this confidence rating is how certain are you that the information that is actually provided is actually accurate, right? So you can also capture other general incident notes, and of course, this is actually optional. Now, the schema also allows you to describe demographics about the victim itself, right? So the main purpose is actually to be able to compare different incidents across different industry verticals. For example, be able to actually compare incidents within the financial services community or, vertical within the manufacturing entities, cloud service providers, vendors from software and hardware, and many others, right? So these demographics include things like identifiers, right? So to identify the specific, demographic or entry. Now the primary industry as well, the country and the state where the incident actually took place, the number of employees the organization actually has, right? Whether it's a large organization or a small organization, and even the annual revenue of that organization, right? So you can go as detailed as actually you want with some of those demographics, right? So now the VERIS schema also allows you to provide information about the threat actors that were involved in the incident, and also the actions taken by that threat actor, right? So also confirmation about, malware and things like social engineering, misuse of applications and infrastructure, and even physical error and environmental descriptions, right? So it actually can go into that detail, right? VERIS also allows you to describe the compromised assets and also to include a variety of those assets, description of the variety of those assets, ownership and management of those assets, so how to describe who actually owns and manage those assets, and also whether those assets are actually hosted locally or in a public cloud. It also allows you to describe the incident timeline. This actually includes things like the discovery method, the root causes, corrective actions, and also if the incident was actually targeted or opportunistic. It also allows you to provide and describe any additional guidance that you actually may want to provide as part of this, data collection. VERIS also include schemas that allow you to describe the impact assessment, including elements like loss categorization, loss estimation, estimation currency, the actual impact rating, and any additional notes that you actually may want to collect. Now, VERIS focuses on the strategic and risk-based information, right? Tactical intelligence, information like indicators of compromise are actually not included within the base schemas because these are all handled in standards like STIX and TACACS, right? So if you're not familiar with STIX and TACACS are, industry-wide standards for the information exchange, threat intelligence information exchange. These standards are actually maintained by the OASIS Cyber Threat Intelligence or CTI Technical Committee. You can obtain more information about STIX and TACACS at the website that I'm actually showing in the screen. Repository of publicly reported security incidents called the VERIS Community Database, or VCDB. Now, this database can be accessed at the GitHub repository that I'm showing here, and there's also an interactive incident recording tool that allows you to enter all the elements of VERIS and your incident data, right? So you can also contribute it to the open source VERIS database, and or use this as an example to create tools internally to the organization to be able to actually use the VERIS schema. Now, there are also several resources at GitHub, including a collection of scripts to search and interact with the VERIS data and the community database. There's also an R package for working with VERIS data and several Python-based tools that you can actually use to use the VERIS and also to format the data and search through the data and organize that data, right? So now you need to know the general components of VERIS and have a general understanding of VERIS for the exam, right? But, not to this actually level of details about each of these tools, but I'm including them here for your reference. There are many different vulnerabilities that can affect an endpoint, and then specifically vulnerabilities that can then be weaponized and converted into malware or malicious software that can absolutely be catastrophic to an organization and to an individual. One of the most prolific pieces of malware and very disruptive as well is ransomware, right? And we're gonna go and touch base on the ransomware attacks a little bit later in this lesson. But whenever threat actors gain access to a system, they usually want future access as well, and they want it to be easy. The attackers can then install things called backdoors. And a backdoor is an application or commands that the attacker can do to allow them future access or to collect information and use that information in further attacks. Many backdoors are installed by users clicking on something without realizing that the link that they clicked or the file that they open is a threat. Still to this date, one of the biggest entry points for an attacker to compromise a system is by leveraging emails and social engineering attacks and phishing, spear phishing, whaling, and many other things that you also learn throughout this course. And again, there's tons of different types of vulnerabilities, but one specifically that I want to talk about right now is buffer overflows and code execution. Whenever threat actors and attackers gain access to a system, they also may be able to take several actions. The type of actions depend on the level of access that the threat actor has or can achieve, and is based on permissions granted to the account compromised by the attacker. One of the most devastating actions available to an attacker is the ability to execute code within a device. Code execution could result in a very adverse impact to the confidentiality, integrity, and availability of the system and the network. Now, remote code execution, or what the industry refers to as RCE, allows attackers to fully compromise the confidentiality, integrity, and availability of a system, and then remotely, so that means many network hops away from the victim, manipulate that compromised system. Right? Now, that type of manipulation in many cases is done using a command and control infrastructure, a command and control server. Now, that command and control server can be another compromised device, like, for example, some unattended WordPress installation that an organization or individual actually left vulnerable in the internet, or it can be even a legitimate service like Dropbox, PhotoBucket. Things like Twitter has been used for command and control and to send information to a compromised system on what other things to do. And that other things to do can be launching a denial of service attack against another victim. It can be to do even crypto mining in some cases, right? But it can be many, many different things that the attacker wants to leverage that underlying system that is compromised. Now, going back to buffer overflows, a buffer is basically a temporary data storage where the length is actually defined in the program, and it's typically buffer overflows are typically performed or found in applications written in C and C++, and basically involves many memory manipulation functions in those languages where the program does not perform bound checking and then can easily override the allocated bounds of such buffer. A perfect example of a function that I'm highlighting in the screen is a string copy function that can cause vulnerabilities whenever you use it incorrectly. Now, in this example here, I'm showing a very small chunk of data, being sent to a buffer, but whenever the attacker sends more information or more data that can be put into that buffer, then that's where the buffer overflow actually potentially occurs, right? So a couple of things that actually can happen. One is that the application will crash, so you will get something like a segmentation fault, and of course provide the ability for the attacker to perform a denial of service condition. Or more catastrophic area is that the attacker can then write to adjacent memory and then perform code execution. Now, there's a lot of different ways that this type of buffer overflows can be leveraged. Now, a simplistic example of how an attacker could then write instructions to a system and potentially cause a local or remote code execution is by using things called shellcodes, which is basically a set of instructions that will be used to manipulate the system, whether it's to launch another application, whether it's to actually create, a stager to then download a piece of malware like ransomware. And I've been mentioning ransomware for quite some time. Ransomware is a piece of malware that, again, is extremely popular in the last few years because criminals have used it to make a lot of money. Basically, the piece of software, this malicious software, will encrypt either files or your whole hard drive. and then it will ask for a ransom. It will ask for basically some monetary reward in order for you to get the key to decrypt those files. Unfortunately, whenever, even if you pay, and typically it's in the form of Bitcoin or some type of cryptocurrency, even if you pay, in most cases, you will not get the key back from the attacker. Yes, there are some cases where you will receive the key back, but typically that's not the case. Now, ransomware has also been used for performing other types of attacks or other types of motives, I will say. The same attack, the encrypting files, but instead of making money, to cause disruption. So in other words, to actually bring the application, the system, or the network down to their knees and of course, perform a denial service condition. And, allegedly, there have been a lot of different ransomware attacks that have been launched by different nation states on where the main purpose was not to make money, but it was actually to perform some type of disruption, right? Now, there are a lot of different types of avenues to basically weaponize a vulnerability. And of course, there's that weaponization will depend on the underlying operating system and so on. But in many cases, actually, it is because of a similar vulnerability like a buffer overflow or anything that will allow you to do code execution. And again, there are many different types of vulnerabilities and attacks that an attacker can leverage. One of the best resources that you can use to learn about the different types of vulnerabilities and their effect and also the mitigations is the Open Web Application Security Project, or OWASP, a website, and specifically the link that I'm highlighting in the screen. Another way that you can learn about the different types of vulnerabilities and their effects and the mitigations is by basically doing hands-on exercises. Now, for this exam, you do not need to be an ethical hacker or a pen tester. So you do not need to perform all these exercises, but through your learning process, it will absolutely help, especially in cybersecurity. Cybersecurity is like math. The more you practice, the better you will become. But it will definitely help to get some type of hands-on experience in some of these attack scenarios. Now, what you're seeing in the screen is something that I created called Websploit Labs, and it's a learning environment that I created for different courses, some for ethical hacking and web penetration testing, and several other ones that I perform, and of course for other books that I have written. Now, this environment has about 8,000 to 9,000 different cybersecurity resources, including sample code, of course, tutorials, and many different exercises. It has at least 850 exercises or so. What it is you can deploy either Kali Linux or Parrot Security, which are the most common ethical hacking Linux, and penetration testing distribution. And there are many others, but these two are based on Debian. And once you download those in a VM, let's say, right, in VirtualBox, VMware, or ESXi, or KVM, or Proxmox, then you run this script. And basically what that will do is will install a whole bunch of tools that do not come with those distributions, as well as different containers that are running intentional vulnerable applications that you can actually practice your skills in a safe environment within one VM. So again, only within this environment, you have over 450 different types of exercises that you can complete, including buffer overflow, SQL injection, and a lot of the vulnerabilities that we have been talking about in this course.